My dear brothers and sisters, welcome to the class. And this is electromagnetism topic in physics. Here we'll cover the following concepts: magnetic field lines, magnetic circuits, and the magnetic flux and the magnetic flux density. By the way, let's start with magnetic field. Magnetic field, it considers the concept of magnetic field. Assume we have two permanent magnets with north and south poles. It's obvious that fluxes or magnetic lines are moving from north to south with this direction. Okay, now this space or region is called magnetic field. Not only that, let's say we have a circuit. This circuit with a source of electricity here and a conductor is called in a coil metal. It's obvious that if we allow the current to pass, there will be magnetic field that will be created, which will create a north and south magnet. This magnetism is created due to the presence of current, and this region, this one, is known as magnetic field, outside the coil and inside the coil. By the way, to understand the concept of electromagnetism, you should know that here we have the word electro, which actually comes from electricity, and the word magnetism, of course, originates from magnet. So the two join to form electromagnetism. So two kinds of energy. So here we are talking about electricity to create magnetism and the magnetism to create electricity. That's why we can create electricity from magnetism, and the magnetism can be created from electricity. Okay, now the important issue here is magnetic field. Very important thing to know. By the way, what is magnetic field? A magnetic field, we say, is a region around a magnet where its poles experience a force of attraction or repulsion. A region around a magnet where its poles experience a force of attraction or repulsion. Let's say we have a permanent magnet with north and south poles. It's obvious that magnetic lines are moving from north to south in this direction. Now, in that way, this happens naturally. While inside, these are magnetic flux lines or magnetic lines, let's say. Now, this spaces is known as magnetic field. Anything of magnetic nature will be attracted if put along that space. Not only that, if we have a circuit of a solenoid like this one with a source of electricity and allow a current to pass, it's obvious that inside the solenoid there will be magnetism that will be created, such that north and south pole will be there due to the source of electricity or source of a current. It's obvious that these are magnetic lines, and this space is known as magnetic field. So that is a magnet which has been produced due to the presence of current, electricity. So this is to say that current carrying conductor carries magnetic field around it. Current carrying conductor carries magnetic field around it. Not only that, even a moving charged particle or a moving charge. So we can also define a magnetic field also as a region where a moving charge or current carrying conductor experience force. Magnetic field is a region where a moving charge or current carrying conductor experience a force. So know that these forces are repulsive force or attractive force. Okay. So let's consider about magnetic field lines. To represent magnetic field, we use lines. These lines are known as magnetic field lines. Note, magnetic field is shown by imaginary lines because we cannot see magnetic field, but we use a line to represent them. Now, these magnetic lines are known as magnetic field lines or simply magnetic lines. Now, these magnetic field lines have properties. So, properties of magnetic lines. Property number 1 is direction. The direction, actually, magnetic lines move from north to south poles of a magnet. Of course, outside. In outside, they show to move from north to south. Consider the following diagram. Let's say we have a permanent magnet like this with north and south poles. It's obvious that magnetic field, as I've said, are moving from north to south in this way. This is the direction of magnetic field. But in south, they seem to move in. But inside the magnet, they seem to move from south to north. Here is a point that magnetic lines move from south to north inside the magnet. Like this one. Consider the following diagram, which is a permanent magnet with north and south poles. So here our magnetic lines are moving out from north, but inside